What is the ordinary differential equation? It's a kind of equation that has only one independent variable, as unknown variable and one dependent variable. So when we talk about differential equation, there are many methods of solving differential equation. We have homogeneous, we have non-homogeneous, we have linear, we have non-linear homogeneous equation. We have all of them. So we have separable variable. But we're going to begin with separable variable. Believe me, if you have attended any class before in calculus, differential equation is a little thing for you, because everything you're going to see on that differential equation is what you have done in calculus. So now, when we see that we have a differential equation, we have what we call dy dx, which is equal to what? A function of x. A function of x. X here, a function of x has to do with anything that pertains to what? X. So here now, when we have dy dx, that the power of the differential is 1, we call it first order differential equation. Of course, this is the first order differential equation. If we have the square y all over dx, x squared equal to a function of what? X, we call it second order differential equation. If you keep on increasing this number here, the order keep on what? Increasing. But for the sake of time, we'll be picking the first one, which is separable variable, method of separable variable. Because I listed the method we use in solving differential equation. We have separable variable method, we have homogeneous, which include homogeneous and non-homogeneous. We have linear and non-linear, which also called Bernoulli equation. We have exact and non-exact. I will be taking you through all this topic. I will be taking you through all this method I just mentioned. But today we are going to start with separable variable. That's the first method we are going to look at. We call it method of separable variable. When we talk about method of separable variable, here we have x, here we have y. We have two variables. So ability to separate each and every one of them, to separate each variable, is what we call the separable variable. You separate them before integrating them. If you cannot separate the two variables to integrate each and every one of them, that cannot be called a separable variable. Now we're looking at the first example of separable variable. The first example of separable variable. Here we have y squared plus 2 into 2x plus 1 dy dx equal to 1, where 0 of 1 equal to. Now this is a differential. This is an example of a differential equation, which is a separable variable. We are going to use a method of separable variable to solve this equation. Now we are given this initial condition here, that after you finish solving, you put in this value, you put in this initial value problem. Why are you putting this value? In order to eliminate every arbitrary constant. Because when you integrate any integration that is not a definite integral, of course there must be arbitrary constant. To eliminate the arbitrary constant, you use this initial condition. Now we're going to solve the question and you see how it is separable, and you're going to appreciate it. Just follow me as we move along. Now we'll start solution. Because in mathematics we believe that every equation has a solution. Now the question says y squared plus 2 into 2x plus 1 dy the x equal to 1, where y of equal to 1. Now, how do we separate it? We divide through by 2 plus 1. If you divide through by 2 plus 1, we have y squared plus 2 into 2s plus 1 all over 2s plus dy dx equal to 1 all over 2x plus 1. You agree with me that this will cancel this, and you are left with y squared plus 2 plus 2 dy dx equal to 1 all over 2x plus 1. Now we are going to I'm going to leave the y here and send the x to this side. I'll have y squared plus 2 dy equal to 1 all over 2x plus 1 dx. Now you agree with me that everything here has to do with x. It has to do with y. Why this one is x. So since I have separated the two of them, here is the x. I will integrate this side with respect to s, integrate this side with respect to y. Now we are going to do it together. Now we introduce the next one. Integrating. So when you integrate, you introduce integral sign, which is y squared plus 2 equal to the integral of 1 all over 2x plus So with this, you agree with me that I'm going to integrate. Here now I can try to split it. And now write it y squared plus y squared dy plus the integral of 2 dy, which is equal to the integral of 1 all over 2x plus 1 dx. Now we can integrate this side this way. We can integrate it direct, but this side we cannot integrate because this is fraction. What do we do? You know, when we are doing integration, a moment to differentiate the numerator, if it is equal to denominator, we will take the in of what? The numerator. But here now, if we differentiate this, it will give us 2, which is not equal to numerator. So what do we do? Now we write this. This is y squared plus y squared dy plus the integral of 2 dy equal to. Now in mathematics, we agree that if you multiply any number to numerator and multiply the same number to denominator, we have not done anything. Now here we have, if I do this, this is 2 over 2, the integral of 1 all over 2x plus 1 dx. Automatically, I have not done anything. I have not changed anything because 2 over 2 is still 1. I have not changed anything about this equation. So what do I do? Let's progress. Here we integrate. If we integrate y squared, what do we do? Y squared will add 1 to the power, also do the same thing to the numerator. We will have y raised to the power of 3 divided by 3. Here, if we integrate this, it will give us 2y. Here, we can push in 2 here. If we push in this 2 here, we'll be having 1 all over 2 integral of 2 all over 2x plus 1 dx. Now, if we integrate this side, here we have y raised to the power of 3 plus 2y equal to, if we integrate this, now if we differentiate this to give 2, if we differentiate the denominator, which is 2x plus 1, it will give us 2, which is equal to the denominator. I will not take the in of the denominator. So I will now have 1 all over 2 in 2x plus 1 plus c, which you call arbitrary constant. Now we have solved this now, but one thing is missing. The thing that is missing, they gave us a condition that here we have y of 0 equal to 1, where y is equal to 1 and x is equal to 0. We substitute into this. So anywhere we see y, we put 1. Anywhere we see x, we put 0. So what do? We put 1 raised to the power of 3 all over 3. 2 into 1 equal to 1 all over 2 in 2 into 0 plus 1 plus c. You agree with me that here will give us, this will give us 1 all over 3 plus here will give us 2 equal to 1 all over 2 in 1 plus c. In 1 is 0. 1 is 0. 0 times 1 over 2 will still give us 0. So we are left with, if we find the LCM of this side, we find the LCM is going to give us 7 over 3, which is equal to c. So therefore c is equal to 7 over 3. Now we'll go back to our equation here, because our constant here is what? C. So we'll replace the c by this 7 over 3. So here we have y over 3 plus 2y equal to 1 over 2 in 2x plus 1 plus 7 over 3. So with this, you agree with me that this is a solution to this equation. This is a solution to this differential equation. This is a